All right. Welcome back. This is lecture 9. This is the last lecture we'll have before our midterm. And today we're going to talk about welfare analysis. This is basically the last thing we need to talk about, the last thing we want to talk about to address the full supply and demand models together. Uh, so let's begin. So first, let's take a step back. Let's go into familiar territory. All right. Let's remember what we saw in our principles of micro class. So in principles of micro, if we had price on the y-axis, quantity on the x-axis, then what you always learn, and if you ever take an econ class at all, is that you'll have a downward sloping demand curve, excuse me, and an upward sloping supply curve. All right. And as we saw in the last lecture, and as we know from wherever we took principles of micro, the point at which these two things intersect, this is what we define as equilibrium, right? Of course, this is nothing new to us. We just need to refresh the memory just a little bit, all right? So when quantity supplied is equal to quantity demanded, let me pause here real quickly and just notice this. Notice this is quantity as a function of price. This is the demand function. When I say demand function, that's giving quantity as a function of price. But we know that it doesn't have to be this way. We know that we can just invert the function and get price as a function of quantity. And this gives rise to what is called the inverse demand function. Right? And this gives price as a function of quantity. All right. Um, they are interchangeable. They produce the exact same curves, the exact same shapes on the graph. It's just a little bit easier to, like when you're first starting out, we usually start with the inverse demand function. We usually start out with, yeah, we usually like to work with this one because we are used to seeing price on the y-axis. And so if y is a function of x, then we have p as a function of q. But there is computationally, there's little to no difference between the two. It's all just a matter of just how we want to display the information. There's no difference between the two. Just always be careful to know which one you're working with. Just want to always be careful and consistent. All right. But back to the topic at hand. All right. So this is what we saw in our principles of micro, wherever we took that class. All right. We know that when the two curves cross, then we have equilibrium. And of course, we know now with our grown-up knowledge that this was a market or an industry level graph, right? We made those distinctions in the last lecture, lecture 8. And the point, this point, we'd get some point Q star, and we'd get some price P star. And then this point, this is referred to as market equilibrium. All right. When we are here, when we are here, the market is in equilibrium. All right. When we are here, that's when supply equals demand. That's when the market clears. All right. Now let's remember another topic from our principles of micro class. What is the area below the demand curve and above the price line? So what is this area right here? Well, we recall that that area is the consumer surplus. That's the name we gave to that area. All right. So the consumer surplus was all of this right here. All right. Now, what about the area below the price line and above the supply curve? Well, we remember that that was the producer surplus. All right. All principles of micro stuff. All right. Just trying to jog the memory a little bit. All right. So this is what we saw in wherever we took our very first microeconomics class. But now let's look a little bit closer. All right. Now we're going to reconsider, we're going to revisit this exact same information, but with our new knowledge. All right. With our grown-up knowledge. All right. So take a little bit closer. What did I define as the consumer surplus? I define that as the demand minus the price. All right. If I defined this for the consumer, I define surplus as the consumer's demand minus the price. Similarly, for the producer, similarly for the producer, what did I define their surplus as? We define that as the price minus the cost. All right. And why do I say cost? Because we remember that the demand curve comes from the consumer's demand, but the supply curve comes from the marginal cost of the firm. We take the upward sloping part of the cost curve, of the marginal cost curve that is, and we consider that the supply curve. But what do these two things have in common? What they have in common is that these are both two different ways of saying the exact same concept, and that is both that in both cases, this is both marginal benefit minus marginal cost. All right. It's always some benefit minus some cost. And we just have two different ways to set that up based on if we're thinking about people or if we're thinking about firms. All right. Looking a little bit more closer, just getting a bit more intuition for this stuff. The idea is that why is this a surplus? All right. Why do I consider this area a surplus or this area a surplus? Because the intuition is that, remember, the demand curve told me that this consumer at this price, at this price, the consumer only wants, I guess I'll have to zoom out just a bit. So at whatever this price is, the consumer only wants this much stuff. All right. The idea is that the demand curve represents what the consumer is willing to pay, and then that price line is what they actually pay. So for a consumer that is willing to pay this much, but they only have to pay this much, this spread, this difference, that's the surplus right there. This guy was willing to pay a way high price, but he only had to pay the market price. And so whoever this guy is, this exact one consumer or this clump of consumers, they are enjoying this much surplus, all right, because their willingness to pay was right here, but they only had to pay this much. All right. And that's the measurement of surplus at this exact one quantity. All right. This is just surplus at one quantity. All right. So I just want to reiterate again, this is willingness to pay minus the price that they actually pay. All right. This will pop up later this lecture, but I just want to give some intuition for this. All right. So this is like the intuition of surplus. And it's the exact same for the producer side of things as well. At this low quantity, producers were cool with taking, like, they were willing to supply, they were willing to sell at this price, but the market price is up here. And so they're earning all of that extra. All right, all of that extra um it's price in excess of cost, and so that's profit. So it's a lot easier to measure a producer's surplus because it's just their profit. They don't have a demand function, they just have the supply curve. But nonetheless, the idea is the same, right? This is what they are receiving, is the price that they sell for, and this is what it costs them to make that thing. All right. It's whatever the price is given by their supply curve. All right. So that's the intuition for these surpluses. All right. It's always a measurement of benefit minus cost. All right. Now, what do we notice? What do we notice? All right. What do we notice at the equilibrium point? At Q star, at P star? Up here, right here, at this exact point, at that exact point on your screen. What is the consumer surplus? Only at that point, not the total, but at that quantity, how much surplus is there on the demand side? Zero, right? So well, this is what I'm getting at, is that if I'm only considering right here, then the the demand curve and the price line are touching. They are exactly together. There's no distance between them, and so there's no surplus at that quantity. All right. Um, Everybody who wants to buy something is able to buy it. Everybody who wants to buy something at a price at or above the market price is able to buy it. That's what I should say. So let me put this one. So what I wanted to say was that when supply equals demand, when supply equals demand, we're seeing that this is synonymous. This is analogous to price equals cost. All right. The total consumer surplus is the sum of all of these individual surpluses. All right. And we just know that once we get right here, there's no more individual surplus. Once we get there, at there's no surplus at the equilibrium quantity. But the total surplus that we've gained getting there, that for certain exists, all right? But I just wanted to give a little bit of intuition about things. All right. So when supply equals demand, price equals cost. And then let me get this pen back. At this point, there is no more extra or excess surplus to be gained. And another way we can put this, another way that we can phrase this is that we can say that there are no distortions. All right, distortions is the key word. We're going to come back to that word. All right. But at the equilibrium point, there is no excess surplus. There's nothing left on the table. Everybody that is able to buy this thing is everybody that can afford to buy this thing is able to. All right. And all the producers that can afford to sell at these prices, they are able. We have, and this is referred to as the market clearing price, but this is all equilibrium. This is all when everything's all good. This is when things are perfect. All right. This is where we want to be. And I just want to take a quick second to remember that, remember, we're only working in perfect competition here. And so that's why at the equilibrium, this is more for the producer side of things, price equals cost. And that gave rise to our zero profit condition. All right. And that's where the no excess surplus comes from, is that in a perfectly competitive market, a firm makes zero profit in the long run. Um, and that's because we are pricing at the level of marginal cost. All right. So where am I going with this? All right. Where are we going with this? Why do I revisit all them old things? Because we want to take a bit closer look now with our grown-up knowledge. We want to quantify what happens when we introduce distortions. All right. Up here, we had no distortion. And up here, we were right here. There were no distortions in this market. So economists care about what happens and how do we measure things when there are distortions. When there are distortions in the market, what are we going to do? Or what are things looking like and what can we do? All right. Specifically, we want to look at who is benefiting, who is harmed, and then how can we restore things? Matter of fact, um, do we even want to restore things? Because to restore things implies why would we want to restore things? Because we think that this outcome might be unfair. All right. But then how do we even define fair? All right. These are all questions that a policymaker, somebody in the government, or somebody that's like at some like market um like somebody who's disciplined in the market. So like the SEC has cares quite a lot about what's going on in trading markets. So think you can think of it like that, all right? But any policymaker, really, the Federal Housing Association is going to care a lot about pri housing prices and rents and stuff like that. SEC is going to care a lot about trading behavior. Um, FTC is going to care a lot about trade behavior as well. So all of these things, policymakers care greatly about analyzing welfare, all right? Analyzing what is the state of the market, who is doing really good, who is not getting such a great deal, and why is that the case? And then as a secondary question is, do we want to do anything about it? And how? How can we do anything about it? All right. So what I'm getting at is that welfare analysis, being able to quantify like benefits and cost for the whole market for everybody, this gives welfare analysis gives us a way to do that. Welfare analysis gives us a way to quantify well-being and quantify benefits and losses. Quantify well-being and benefits and losses. So today and in this lecture and all of the pre-midterm stuff, we're going to just cover the classical examples of these distortions. We're going to just look at taxes and subsidies. We're going to look at price controls, and we're going to look at trade agreements, how do trade policies affect the market. Um, Later on, after the midterm, we're going to look at other types of distortions that can arise due to, these are the kind of the fun ones too. But the easiest one is what happens when somebody has market power? What happens when somebody can mark up prices? Or even collude. If it's like a very small market, they have a lot of market power, then they can collude, they can work together and make a great deal of profits, right? We can kind of understand how this would come about. So distortions can arise due to market power or and collusion or cooperation. But some of the more fun ones too, at least in my opinion, some other fun ones to think about are distortions that are due to asymmetric to information differences. So asymmetric information or imperfect information that can cause distortion if we're trying to bargain, if we're trying to get a contract going, and somebody has more information than the other, then probably the person with more information is going to benefit, right? And so that's how we can say that distortions arise due to asymmetric information. And then lastly, if you're interested in finance like I am, then you will see that distortions will arise due to risk and uncertainty. I say finance, but this actually goes along with micro and macro stuff too. So like how does a person respond when how does this person change their behavior when there's a risk of losing their job? Or how do we change our behavior when we know that the economy is kind of in a downturn? All right. So risk and uncertainty can cause distortions and can affect outcomes as well. All of these things take us away from the equilibrium and they'll put us somewhere else. And we call these distortions in the market. But for today, we're going to just look at the base cases. All right. Things that we've been looking at um, since our principles of micro class. We're just going to look at them just a little bit closer. All right. So let's begin. How do we begin to measure this? All right. How do we even begin to measure this? Well, we need to define total surplus. All right. Total surplus, most explicitly, is what is the social value of something minus the social cost of something. So if we're looking at markets, what is the social value of this thing being in existence? What's the social value of smartphones existing? All right. And then we also got to consider what is the social cost. This could be the cost to the firms. It could also be the cost to society due to pollution, due to any externalities that you can think of, or maybe some social values have some externalities as well. We won't consider too many externalities in this class. Probably, yeah, probably not in this class. Um, but you can think of all of these things going into social value if there's a good, positive spillover, a positive externality, or contributing to social cost if there's a negative spillover and there's a negative externality. All right. Now we've probably seen this before, all right, but the way you're familiar with it is what we just saw on the first page. All right, is that this is consumer surplus plus producer surplus. But the full thing is what we define as the total surplus. So of course, this is the demand curve. This is the supply curve. We've got a quantity and a price. So of course, we know that, like as we just saw on the last page, we had the consumer surplus and the producer surplus. The total surplus is the sum of the two. All right, this total surplus is simply the sum of the two. Maybe I'll do that one as green. I'd like to use my notation is like blue for consumer surplus and red for producer, or blue for anything with demand, red for anything with supply. But it's not at all necessary, and that's not at all standardized. All right. So we know that this is what we define as the total surplus. All right. It's the social value, right? All of that demand minus the social cost, which is the cost of doing business. So this whole area right here, this is the total surplus. All right. Now, now this is just the total surplus. And so how do we decompose total surplus? Well, the value of things minus the price you pay, the value of things minus the price you pay. This is what goes to consumers. All right, this is what goes to consumers. We're talking about demand, so we're talking about value, talking about utility. And so all of that utility, all of that value goes to consumers. So that's the benefit, but we must always subtract out the cost, right? For the consumers, the cost is the price paid. All right. So this is what the consumer gets. That's their benefit. And then their cost is the price they have to pay. On the other hand, what about for the firms? Well, their benefit is the price that they receive, the price that they sell the something for. And the cost they have to pay is whatever the social cost is. I guess I should put an asterisk here. This really should be a private cost. This really should be private cost. But for simplicity, since we're considering no externalities in this case, then social cost is exactly equal to private cost in the case of externality. So maybe instead of crossing it out and claiming that it's a typo, I'm going to just add the asterisk and say social cost equals private cost if and only if. If and only if. That's what IFF means if you haven't taken too many math classes. If and only if. Uh, this means that there exists no externalities. A backward Z means there exist, and a line through it means that there does not exist. All right. So social cost is exactly equal to private cost if and only if there are no externalities. All right. So that's the idea. That's the idea of like measuring welfare. We're always trying to get at how do we measure? We're always trying to get an idea for, I should say, what is the benefit going to consumers, and then how much profit are the producers making? All right. That's the intuition of what we're getting at here. But how do we actually go about measuring these things? And I'm not talking about just the areas of the triangle, right? I know that you guys can take an area of a triangle, but how do we actually get these measurements? Well, we see what we're going to see in these next pages that we have a demand curve and a supply curve. So think like right now, think back to where does the demand curve, where do we see in our lectures, where does the demand curve come from? And on the other hand, where does the supply curve come from? First, let's start with the demand side of things. Let's start with a consumer surplus. All right, for consumer surplus, we'll need two things, two ingredients. We're going to need expected value and real expenditure. And we define consumer surplus. Another way to define it is that it is the difference between a consumer's willingness to pay, which is the expected value, and then the actual price that they pay, which is the real expenditure. All right, so we need these two things to be able to measure consumer surplus. All right, so how do we measure expected value? All right, how do we measure expected value? You use a demand curve. All right, we use a demand curve, and what did we see? We saw if I saw something like this is like maybe a certain challenge problem that we might have just finished up. Uh, you would see something like this. This is the demand curve. All right. The idea was that right here at this price level, at this price level, at this price level, we had these different quantity demanded. So at P1, P2, and P3, this gave us at P3, it would correspond to this one, and this one. All right. So we know how a demand curve was derived, right? Just to refresh ourselves, from the utility maximization problem, we get a demand function or a demand curve. And then this is what I had you guys derive in the challenge problem from the last problem set. You get a demand function, which would be like a quantity of X as a function of its price. Or you can take the inverse of it. The inverse demand function is exactly equal to price as a function of quantity. So what's the price that consumers are willing to pay for X as a function of the quantity that is supplied or the quantity that's available? Sorry, not supplied, but that's available. Consumers, this is the inverse demand function. Sorry, let's make this just a little bit cleaner right there. One more down. There we go. All right. So from the consumer's problem, we got a demand function. And then from that demand function, if we just invert it, swap our X's and our Y's, then we get something like this. All right, we get this downward sloping bowed curve. And this is our demand function. And this is what we define as the expected value. All right, this is what we define as the expected value. Given that only quantity Q1 is available, if there's only Q1 amount, I'm sorry, Q3, if there's only Q3 amount of things available, then this consumer is willing to pay this much for it. But if there's a whole lot more available, then we're gonna be willing to pay a lot less because there's more, it's more plentiful, there's a lot more to go around. All right. So in that way, now if we had, if we consider what I'm doing, all right, consider what I'm doing. Um, Let me actually say one more thing. The expected value, the expected value is the area under the demand curve. So the expected value is the area under the demand curve. This is our value, this is our benefits. This is that benefit part of the consumer surplus. If we, and I just want to make a note that if we had Math 124, if Calc 2 was a prereq for this class, then we would do integrals. Sorry, I said 124. If we had Math 125, if we had Calc 2 available, then I would make you guys do integrals. But and since we only require Calc 1, we can only use derivatives. Uh, then we will just use geometry. But if we had Math 125, then we would use integrals. But for now, since we do not, then geometry will have to be sufficient. All right. So the area under the demand curve is the expected value. And this is this should be connotated with willingness to pay. You'll see this phrase thrown around a lot. I know I like to throw it around a lot. All right. So that's how we measure expected value. But remember, there's more to the story, right? If that's how we measure expected value, that's how we measure we measure that with the area under the demand curve. We still need to subtract out the costs, all right? Now the cost is easier. The cost is real expenditure. And that's simply the price paid for the item. So with that, we have if that was our demand function, that's our price. Of course, there's only one market price, right? There's at least in our simplified model, we just assume that everybody pays the same one market price. And so you'll have something like that right there, like that. And so this will give us a Q star and then a P star. All right, this is the competitive market price. So we have a P star. And in this way, the consumer surplus is everything below the demand curve because that's all of the benefit. Maybe I could even, I always do this one when I'm teaching principles, that they're getting all of this benefit, but they have to subtract out everything that it costs to get there. And so what we're left with is that this is the consumer surplus. All right. So altogether, the consumer surplus is that expected value given from the demand curve minus the expenditure, which is simply the price paid for the item, right? And then this is what it looks like in a perfectly competitive market. And that's why we have a flat price. All right. And that's how we do the consumer side of things. That's how we measure consumer surplus. What an economist does. So this is all graphs and this is all theory. All right. This is as an aside, this is probably the most theory heavy class that you guys will take in your if you're a finance major, then this is probably pretty much the most theory heavy class you'll take. If you're an econ major, it's still pretty much the most theory heavy class you will take, unless you take econ 400, which is advanced micro. And intermediate macro is also pretty theory heavy, but it's a bit more, I don't know. You would tend to use more applied examples. Um, but yeah, this is a lot of theory. So how do we do this in the real world? We clearly don't use, this was all made up, not made up, but all of these things were very popular back in the day before computers, right? Before computers, we had no other choice but to try and just come up with a mathematical framework that matches what we see in the real world. Now, these days, we have a lot more computing power. We have a lot more statistics and data available to us. And so we can actually go and estimate these things. Now, modern economics, we test all of these theories. We are able to test all of these theories. And as I've said in a past lecture, um, An applied economist, an industrial organization economist, their whole job, the whole way that they make their paycheck is that they go and they estimate all of these demand functions. They estimate demand functions for a market, not just for a firm's product, but for the market as a whole. And then they will also do their best to estimate like supply functions for a market, talking about what is the supply function for the market. And then they use this to quantify and calculate what is the hypothetical equilibrium, and then where are we at? Are we at the equilibrium? Are we far away from it? And then from there, businesses or governments, market regulators will use this information to try and make things better. If you're a business, you're gonna make it better for yourself. You're gonna figure out, well, hey, if people are demanding my product and I could be charging more, then I'm probably gonna charge more, right? Or if you're a market regulator, you're seeing, wow, producers, the supply side is earning a whole lot and consumers are kind of getting screwed. Then you're probably inclined to enact policy to change that, to even the playing field a little bit. But they do that not with just theory, but they do that with data. And so they will go and estimate all of this stuff with statistics, some very fancy, very high tech statistics. Um, and then they will put all of this together and come up with their reports with all of the information that we know here from econ theory, but what does it look like in the real world? Right. So that's just a taste of what an economist actually does. And I'm learning this for no reason, I promise you. All right. But so that's how we would measure consumer surplus. All right. They would estimate the demand curve or solve it analytically, like we do here in class with this theory. They would estimate that, and then they subtract out what is the price that they pay. And that is our consumer surplus. Now, what about producer surplus? This is a lot easier, right? Because we don't have to hypothesize utility functions. We don't have to guess the firm's utility function because they don't have a utility function. They have just what is their money coming in is their revenue. All right. So the benefit side of that story, on the firm side of the story at least, the benefit side of the equation is just revenue, right? Money coming in. And then what is the cost side of that? What's the cost of doing business? Cost of production. These things always have numbers attached to them, and they're much easier to calculate. All right. So of course, for the firm side, we need revenues and we need cost of production. And what do? Well, we define producer surplus as a difference between price received and willingness to sell. All right. And I just want to say, saved this space here for to a brief note that the demand curve is to CS is to CS as the supply curve, which we know is the marginal cost curve, is to the producer surplus. All right. And what do I mean by that? Well, we remember that the supply curve is the upward sloping part of the marginal cost curve. So you'd see something like this, that this would be the marginal cost curve, but we also call it the supply curve, the industry supply curve. If we had that and that, then let's do one right here, and one right here. Then the idea is pretty much identical. It's just flipped. All right. Because what is the benefit for the firm? I keep saying it's the revenue. It's the price that's coming in. So for the firm, the benefit, like for this, if we're at P1, and I should do Q1, Q2, and Q3. So for the firm, you have price times quantity. All right. That is revenue. It's price times quantity. Geometrically, it's just that area of the blue rectangle right there. And then what is the cost? Well, the cost is going to be your marginal cost times your quantity. All right. So your marginal cost times your quantity. Let me actually erase the blue part right here. Let's do this with the P3 and the Q3. I think that's a better illustration. All right. So for the firm, if we're at P3 and Q3, suppose we're right here or right here, then then the revenue is P3 times Q3, right? And we get the area of this rectangle. And then what's our cost? Our cost to get here is all of this right here. All right. It's all of our marginal costs at each of those quantities. Because remember, marginal cost is what we pay per unit. And so that per unit cost is adding up right there. And that's why all of this is our producer surplus. Let's do this in green. All right. So that gives us the producer surplus. All right. Just a quick illustration to get the intuition for these things. And then just because I want to be consistent, let's go ahead and label that one a consumer surplus. All right. And those two things are a bit closer look at how do these supply and demand curves come about, and then how do we measure what are we exactly meaning by consumer surplus and producer surplus? It's always a surplus, it's always some excess, right? Then, of course, all together, what do we have? We have what we saw in principles of micro with our demand, our supply, our Q star, our P star. We had the CS and the PS. That's what we define as the social surplus or the total surplus is just the sum of the two. All right. Very good. That should have been a lot of review. If not, then great. But it should have been a lot of review. There wasn't too much new there. And to be honest, this lecture is going to be a lot of review. Um, we just need to come at it with a little bit more information now. All right. So the next part is why do we even care about measuring welfare and surplus? Well, I gave a bit of the intuition earlier. All right, we want to see who is benefiting and who's getting screwed. Right. The goal of an economist, the goal of a social planner, is to maximize net benefit from all of the resources available. All right. So the goal of a social planner is to maximize net benefit from resources available. How do we do this? Well, we need to measure net benefit. We need to measure consumer surplus and producer surplus, and this gives us net benefit. All right. So in econ theory, efficiency is the point at which total surplus is maximized. Now, notice this is total surplus is maximized. I didn't say consumer surplus, I didn't say producer. We just know that the whole everything is maximized. And that is what we define as efficiency. Why do I single that out? Because it doesn't necessarily mean fair, and it doesn't necessarily mean unfair either. It always depends on context. All right, it always depends on context. Who do we really want to be doing good here? Is it good for the producers to get a whole lot of surplus, or can we incur some deadweight loss in order to give the consumers a bit more of a fair deal? Or is it the reverse, where the consumers are benefiting a ton, but our producers are kind of hurting? Maybe we need to transfer some of that surplus from one party to the other. All right, this is why we care about measuring these things, because we can get an idea of where are people sitting at, who's getting a good deal, who's getting screwed, or are things generally balanced. All right. So with that being said, remember the distortions we talked about? Distortions can create deadweight loss. And a deadweight loss in its exact definition is a loss of social surplus. So any distortion, basically any distortion in a market will lead to a loss of surplus. All right. And then as I alluded to, I just have a little note here that this can also, another way that this can take form is that somebody's getting excess surplus. All right. But it comes at the expense of others. So with this idea of welfare analysis, with the idea of measuring welfare in this way, we can help policymakers enact policies that cause the least damage as possible. Because if we intervene in a market then chances are we're going to create some deadweight loss. And so we just want to minimize the deadweight loss. All right. We want to minimize the damage that we're doing. All right. But in order to minimize something, we must be able to quantify it. All right. How can I minimize a function if I don't know what the function looks like? It's impossible. All right. And the last note is that in econ theory, we see that the competitive outcome leads to efficiency. In other words, perfect competition maximizes total surplus. This is a recurring theme in econ, so you should get used to that. That perfect competition, true perfect competition, will maximize total surplus. Any deviations from perfect competition will take us further and further away from efficiency and further away from that maximum total value. So in the final section of this class, to wrap up, I should say, in the final section of the first half of this class, we're going to analyze a few of the effects of a few of the distortions mentioned. All right, and these are the ones I mentioned at the beginning of this video. We're going to look at how do we deal with taxes and subsidies, how do we deal with price controls, and then how do we analyze trade policies like tariffs. All right, so let's begin. Let's start with taxes. All right, let's start with taxes. All right, and then before I even begin the problem, I'm going to give you guys some notes. I'm going to give you guys some notes. Let me save, how about this much space here? You should have this information already, but just in case, in any case, if we don't, I got you. I'm going to give it to you. That a sales tax, when we're talking about a sales tax, this is on the consumer. This is on this is on the consumer. All right. In contrast, when you hear the word excise tax, this is on the producer. All right. So that's just to begin. Also, also, I'm not going to do any examples right here, right now, but we should know the tax burden, depending on where you took your principles of micro class, you might have seen this part, but we should just know that the tax burden, like who is going to pay for the tax? If it's a $10 tax, that tax could be split up. Like the consumer can pay for some and the producer will bear the cost of some. Like the idea, if something costs $100 and then now they added a $10 tax, then is the new price 110? It could be if we want to make the consumer pay for everything. But what if the producer doesn't want to make the consumer pay for everything? Maybe they say, I'll only pass on $5 to the consumer and I'll take a $5 hit. That could very well happen as well. All right. I had to plug my laptop in. So that could happen as well. All right. So how do we, using economic theory, how do we define who should pay what? Well, we call it refer to it as tax burden. And we say the consumer pays, this is going to be a fraction. So they're going to pay a percent of the tax. And the fraction, how do they compose the fraction? They use elasticities. So they use elasticities. I should say this times 100%. So if you sum up the elasticities, the consumer pays their fraction of the elasticities, and the producer pays yeah, this is how much percent of the tax that each of the parties pays. All right. I don't have any examples here today, and I won't include any on the midterm, but we should just know this going forward. All right. So the tax burden, how do we decide who should pay how much of a tax? is determined from the relative elasticity. So we have a price elasticity of demand, and we also have a price elasticity of supply. And so these things help to determine the optimal share of the tax, which should be borne by either the consumer or the producer. All right, great, great. Now let's actually get on to the example. All right, moving on to the actual example. Let's consider a tax example. Let's consider, suppose that the demand is given by P equal to 140 minus Q, and suppose that supply is equal to 20 plus 2Q. And I'm going to just interject here and then say, remember, this is inverse demand function. And that's why we have price as a function of quantity. All right. You can always go from one to the other. All right. You can always go from one to the other. All right. So what do I mean? Is that let's write over here. If I have my equations, call them 1A. All right. 1A and 1 and 2A. Then I have my demand function. Is price equal to 140 minus Q? Right. So I have the demand function is 140 minus Q, and I have the supply function is 20 plus 2Q. I can the if I'm given it in the other way, like quantity is a function of price, all this is the inverse. All right, all this is the inverse. So I have 1B and 2B, where the demand is actually pretty easy. All I do is send Q over to that side and then send P over to this side. And then so I have quantity is equal to 140 minus P. That's quantity demanded. And then somewhat the reverse, all right? Um, from 2A, I want to send 2Q over to this side. I want to send P over to this side. So that would look like 2Q equals 20 minus P. All right. Where my thing go? There we go. All right. So I would have 2Q equals 20 minus P, but I want Q by itself. So this would become Q equals 10 minus 1/2 P. All right. I didn't want to write this. I didn't want to clog up the screen. So I'm just going to write that bottom line. This is how we do it. All right. To get to recover the supply function, it is done in that way. And then that is how I'd get quantity supplied equals to 10 minus 1/2 P. And then this was the inverse demand function. And this was the demand function. And both work. We just must always take care to be specific and be consistent about which one we are working with. All right. So if that is the case, why do I even bother using this one? This one's a lot easier to work with when you consider these distortions. On the other hand, the other one's easier to work with for most other cases. So it's really just context dependent. Just be consistent, all right? Just be consistent. So with those two things in mind, um, I guess as a last thing that I wanted to say is that another interpretation is remember demand is willingness to pay. So consumers are willing to pay 140 minus however many things are available. So their willingness to pay is highest when there's the least amount of things. If there's one or even zero, they're willing to pay a lot of money. But if there's a whole lot of stuff to go around, they're not willing to pay that much. And then the converse is that we have the consumer or the producers, they're willing to sell. Well, if people are not, if people, how should I say this? We have a willingness to sell, and if quantity is very high, then we are willing to sell. Mm, I guess the intuition is best understood with the demand side of things. So, and honestly, it's not all too important, but I just wanted to give some intuition for like the inverse functions. Um, nonetheless, let's actually get to solving this problem. Right? So you might see something like this, like maybe we even saw something like this, like on the homework that's due tomorrow night. Um, like suppose demand is given in this way, supply is given in this way. So I want you to calculate what is the equilibrium price, equilibrium quantity, and consumer surplus. So you want to give yourself some space here, and to calculate, go ahead. Let me talk and then speak. I'm sorry, let me write and then speak. Okay. So to find equilibrium, we want to always to find equilibrium, you want to set supply equal to demand or demand equal to supply, whatever have you. This will give us in this form, this will give us a quantity. This will give us Q star. And then from here, plug Q star into either of the functions to get P star. All right. So you want to set these two guys equal. You want to set these two guys equal and then solve for the Q that makes it true. So if we have 140 minus Q for the demand side, all right, 140 minus Q. So demand equal to supply. We have 140 minus Q should equal 20 plus 2Q. Then we just want to get everything. You guys know how to solve algebra problems, but we just want to get Q on the everything with Q on one side, everything not Q on the other. We get 120 on this side, 3Q on this side, and then we know that Q star is going to be equal to 40. And if Q star is equal to 40, then we can plug this in to P equals 140. P star equals 140 minus Q star equals 100. All right. So here Q star, comma P star is equal to 40, comma 100. So that's equilibrium in this graph. I'm sorry, in this market. And then graphically, this would look like this. This is going to be good. Let me move this up just a little bit. There we go. Make that a little bit bigger now. Now that I have some space. And then our functions were 140. They don't have to be super accurate, all right? As long as the numbers, the intercepts are right, then the slopes, they don't have to be to scale. So this is our demand, and then our supply was 20 plus 2Q. You know, that was just gonna have a steeper slope, should have roughly twice as steep of a slope. We know that quantity, Q star is going to be equal to 40, and then P star is going to be equal to 100. And then what do we remember? We remember that our consumer surplus is this area, and our producer surplus is that area. All right. So that's how we answer the first half of the part one. And then to actually calculate, it's just the area of the triangle. So what is that gap? That distance, this area, that measurement of the triangle is 40. And then the width, sorry, if that was the height of the triangle, then what is the base? It's simply this measurement. I'm going to take my scribbles away. So producer surplus is equal to, we have 40 times 40 times 1/2 because we're working with a triangle. So I'm sorry, that's consumer surplus. I did the color right. I said it wrong. Consumer surplus is 80, equal to 80. Meanwhile, producer surplus is equal to, well, now this gap is our height of the triangle. The base is the same. So we'll have 80 times 40 times 1/2. And that, of course, is going to equal 160. And then I don't think I asked for this, but it's always good to see total surplus is equal to 240. All right, so that's the maximum surplus we can get in this market. Next, part two, let me just highlight. If this was homework assignment or your test, then you want to either highlight your answers or box your answers. All right, always make it easy for me to find your answers. The work, you don't have to make it easy for me to find your answers. All right. There we go. So that's our answers for part one. All right. Then they ask us, how does a sales tax of $6 per unit change our answers? All right. And that's why I started off with all of this stuff. That a sales tax, we know that's going to go on the consumer side of things. So now, what do? A sales tax, this, I wanted to write this, but I'm losing some space. So now a sales tax, um, all right. With the sales tax, you want to, of course, this shifts the demand curve to the left. All right. Let's look at, here's our graph. This shifts our demand curve to the left. How do we do that? To go from here to here and keep the same slope, what changed? The intercept changed. All right. How do we change the intercept? You're going to subtract a number from that curve. So with that being said, a sales tax, you would subtract tax from 1A. With an excise tax, you would add the tax to 1B. Remember, 1A is the demand function, inverse demand function, and then 1B is the inverse supply function. Keep those things right there. All right. So now the demand function is given by P equals to we had 140, but now minus a $6 tax, they asked. $6 tax. Minus $6. And then minus Q. All right. And then the supply side is unchanged. P is equal to 20 plus 2Q. I don't know why it goes away. All right. So now we have 134 minus Q, and then this guy is still the same. All right. Now take a few moments. I'm gonna let you guys I won't show the calculations now. The calculations are the exact same as in the first part. Take a few moments and try to find equilibrium right here. Pause the video. Take a few minutes to try and find the new P star, Q star, and then the new producer surplus and consumer surplus. All right. Pause the video now and come back when you think you have an answer. Okay. For the first part, oops. Okay. For the first part, to find Q star and P star, you would set the equations equal to each other, and you should have got that Q star is equal to 38 and P star is equal to 96. So P star is equal to 96. And we think, huh, that's a little odd. P star was higher. P star was higher before the sales tax. What's going on? Well, consider the consumer pays the sales tax. All right, the consumer pays the sales tax. So the consumer pays 96 plus the 38, the $6 sales tax. All right. So they don't just pay $96, but they pay 96 plus 6. So they actually pay 102. So 102 is the price paid by consumers. 96 is what the producers receive. All right. So what I want you to do is try and graph the producer and the consumer surplus. Make sure you graph this market now with the sales tax and go ahead and give it a shot. And if you can't get it, or if you think you got an answer, play the rest of this video. But we will see how we work this price paid versus price received, how this works out in the graph. So pause the video now, or let it run if you've already done this. But pause the video now and try to graph the new price and quantity, and also the producer surplus and consumer surplus. All right, so here's what I was getting at. So your graph should look like this, roughly like this. All right. What we noticed is that the demand curve did in fact shift to the left. It shifted down. The intercept, exact to be specific, shifted down by the 6 units, by the $6. And so we have a new equilibrium. All right. And we do see that the equilibrium occurs at quantity equal to 38. So the sales tax makes the quantity, the equilibrium quantity decrease. Um, and then this is where I was getting at with why do we get price equal to 96? Well, that producer takes home 96 bucks, but what is the price that the consumer pays is at 102. All right. And then that difference, that spread is exactly the sales tax. All right. So graphically, this is all the consumer surplus now, and this is all the producer surplus now. And then this green area is the tax revenue. All right. Because there's what is our quantity? Our new equilibrium quantity is 38. And then if we did 38, that's this measurement times how many things are being sold. I'm sorry, 38 is the number of things being sold, and that's this measurement, excuse me. And then times what is the tax per unit? That's this measurement, it's 6. So all of that green area, the tax amount times the number of things that are sold, that's the tax revenue, total tax revenue. And then I have that as 3. I have that as 3. So I went ahead and did 3 in advance. Tax revenue is equal to the $6 times 38. And then we have that as 228. Yeah, yeah, it should be right. Yeah, 228. It's exactly that equal that area there. And then so let's take a look comparing this graph, the post-tax graph with the pre-tax graph. What do we notice? What is the difference? Well, one has green on it, but more seriously, uh in the post-tax graph, we're missing out on all of this area right here. This area right here is exactly what we refer to as the deadweight loss. All right. Because it's harming the consumers, it's harming the consumers, they have to pay a higher price. All right, so that's not good. It's harming the producers through the means of, since consumers have to pay a higher price, they're not going to want to buy as much stuff. And if consumers are not buying as much stuff, producers are not making as much money. So the sales tax is harming both people, um, even in spite of the fact that consumers are paying 100% of the tax, it still will affect the producers. All right. It's not even beginning to address, like, what if the producer pays some of that tax? Well, then we're going to cut into that producer surplus even more. So now the new consumer surplus, CS prime, is equal to, it's going to be 140 minus 102. So we know that measurement has reduced. 140 times, sorry, not times, minus 102. And then we know that the quantities, equilibrium quantity is just 38. And then it's area of a triangle, so you have to do base times height times 1/2. Meanwhile, the new producer surplus is this amount now. So 96 minus 20. And then, of course, the quantity is 38. And of course, we have to do the 1/2. And when we punch these things into our calculator, what do we find? We find that the new consumer surplus is 722. The new producer surplus is 1444. And if we add those together, the new total surplus is 2166. And if we compare that to what I had written above, except that these are supposed to have an extra zero and an extra zero right there. And then this final one's supposed to have two extra zeros, or actually just one. So we see the change, all right? We see the change. We see that the consumer surplus has reduced, producer surplus is also reduced, and total surplus is also reduced. And so the deadweight loss is the difference between the two. That it was 2,400 minus 2,166, and that's 34, 234. I think so. Yeah, I think so. Equals 234. Yeah. And then, of course, the tax revenue that was generated was 228. But what do we see? What do we see? Is the tax revenue, um, is the tax revenue enough to make up for the deadweight loss? Well, the revenue that was generated is 228, but the deadweight loss is 234. So we still have a net negative. All right. Actually, let me actually correct myself. This this is not actually the deadweight loss because I forgot to deadweight loss. Let me move this. I should have done this graphically. All right. Because what I calculated, the deadweight loss, how I gave it to you guys, is it should be the area of this triangle. So alternatively, what I could have done, if I could edit the video, I would, but it's kind of difficult, so I'm not going to. But just know the deadweight loss, if we do just the area of the triangle, we know that that is 102 minus 96, right? It's actually that one dimension is the amount of the sales tax is equal to 6. And then what's this dimension? 40 minus 38 is 2. and then times 1/2. So the deadweight loss is 6. All right. The deadweight loss is 6. All right. What did I calculate, mistakenly calculate down here? What I calculated down here was what is the change in total surplus? Change in total surplus. Well, our new total surplus was 2166. The original surplus was 2400. So the change in total surplus is actually negative 234. All right. That is this. So we compare this to the tax revenues that's generated. So we see that we changed our surplus by a value of $234, but our tax revenues raised $228, but the loss of surplus is greater than the tax revenues that were generated. All right. And that exact difference is the deadweight loss. All right. And that's how we calculate these things. All right. Now, with typos corrected, this is exactly what we need to answer all parts of that question. And that's how we want to handle a tax question. Now, next, we want to consider what about a subsidy? All right, what about a subsidy? Want to do the exact same thing, um, but now we want to consider, remember, a subsidy is where they pay you. All right, you're not paying extra, they're paying you some money. All right, and here's where I just want to add a note. A subsidy is simply a negative tax. A subsidy is simply a negative tax. All right. So you do the exact same thing, except you're going to flip the sign of the tax. So if the tax was subtracting from the consumer, then now a subsidy will add to the consumer if it's a consumer subsidy. And then for the producer, remember I had written up here that an excise tax adds to the producer, the supply side of things. Well, a producer subsidy is going to subtract. So specifically, consumer subsidy, add the subsidy to demand. Whereas for a producer subsidy, you want to subtract subsidy to from supply. All right. So with this in mind, now we know how to handle subsidies. All right. So with this in mind, consider this example right here on the board. All right. So now we've got a new set of demand and supply equations, and I want you to calculate pre-subsidy equilibrium. Give me the price, quantity, consumer surplus, and producer surplus. And then show how these things change when you when the government says that we're going to give consumers a subsidy of $30 per unit. How does this change all of your results in part one? And then in this case, now that we're giving the consumer something instead of charging them more, now does the consumer surplus outweigh the deadweight loss? Take a few moments. Try this question on your own and um, resume the video when you think you got an answer, or if you just want to see the answer revealed. All right, go ahead now. All right. So if you've either given this a try on your own, you might have realized it's a bit trickier once we get to those later questions. Or if you're just playing the video back, let me show you how it's done. All right. So just like we did in the last example, before anything happens, to calculate equilibrium, we just said demand equal to supply and solve. All right. And so that part was pretty easy. That part was pretty easy. All right. So you set demand equal to supply, get these two equations. And then what I've done is I think it's probably helpful, a little bit helpful to, even though this might not represent exactly something, give these little superscripts to know what we're dealing with. So superscript of D for demand and quantity demand, the D superscript on the quantity for quantity demanded. So that one actually means something. All right. So set this equal to this and solve for the Q that makes it true. What you will find is that Q star is equal to 100. All right. And you plug that Q star in to either of the function, doesn't matter. And you will find that P star is equal to 150. So in this pre-subsidy, you'll get a graph that looks like this. And the equilibrium point, where does supply equal demand, happens at a quantity of 100 and at a price at 150. And then if we were to calculate the welfare, the consumer surplus and the producer surplus, we would find that the consumer surplus is the area of this triangle, which is one of the measurements is given by 200 minus 150. The other measurement is simply the base, which is 100. And you'll get that consumer surplus is equal to 2,500. And then if you do the exact same steps, you'll find that producer surplus is equal to 5,000. So our base case, our baseline is that total surplus is equal to 7,500. All right, so that part was easy and you should have gotten that far on your own. But now, how do we think about the subsidy in this setup? Let's have a look. Remember what I said up here. For a consumer subsidy, you want to add the subsidies to the demand. It's simply a negative tax. So whatever we did for taxes, you just flip the sign. All right. So since this is a consumer subsidy, in the post-subsidy case, we will add 30 to this inverse demand function. We'll add 30 to this equation right here. So we add 30 here, supply stays the same. And now we want to set these things equal to each other and find the new equilibrium. All right. So I combine 230. I set them equal to each other. And I find that when I set these things equal to each other, the quantity Q, which makes it true, is 120. And if Q star is equal to 120, I plug that in and I find that P star is equal to 170. All right. So if we were to plot these things, notice here was our original. So of course, quantity increased. And then now P star, remember P star above was 150. P star now is 170. This makes intuitive sense. If the government's giving out money, then of course prices are going to go up. But is this a good thing? All right, is this a good thing? Surely this has to cost somebody something, right? And it will. Let's see how. All right. So now we'll do our welfare calculations and we'll do consumer surplus. Remember, this is our new demand function, so it has a new intercept. And then the new market price is 170. So the consumers are getting this much surplus. And it looks like if we do that math, what is the area of this triangle? You'll find that the area is this much, 3,600. Compare that to originally. Consumer surplus originally, 2,500. So this is looking like a good deal. This is looking like a good deal. And then on the producer side of things, well, now they're selling more things for a higher price. So this is also looking like a good deal. We see that the producer surplus, that triangle has grown in area. And then when we do the actual calculation, what is that area? We get a producer surplus of 7,200. And that's a lot more than the 5K that they were getting originally. So at first glance, we might think, yes, this is great. We grew the total surplus. Both sides of, consumers are happy, producers are happy, everything's good. But we're forgetting something. Who's paying for the surplus? The government is who's paying for this? All right, who is paying for this? All right, the government is paying for this. So when we consider that part, we need to consider tax expenditure. Tax expenditure. Remember above, it was the government was collecting a tax, so they were generating revenue. But now the government is giving out subsidies. They're giving out money. This has to come from somewhere. All right, we pay taxes. So to subsidize something, they're going to tax it from somewhere. All right. So in this case, the tax expenditure is 30, right? $30 subsidy times how many things are being exchanged in equilibrium? It's 120. So the total tax expenditure is 3,600. We must include this in our total surplus calculation. So total surplus is going to be equal to 3,600 plus, let me color code them as well. It's the consumer surplus, the producer surplus. We add those two things together, but then we must subtract the tax expenditure. All right, somebody's paying for this. All right, so what is the total surplus now? Well, now those things will cancel, and now the total surplus is simply 7,200. Now we compare that to our original, to our baseline case. What do we see? Total surplus was actually still higher in the original case. All right. Total surplus has decreased by 300. So let me get, so for part one, we did part one right here. For part two, we just did that. We got a new Q star, P star, consumer surplus and producer surplus. And then now we have our new total surplus. And then what do we notice? We notice that, yeah, well, consumer surplus went up. Consumers enjoyed some benefit, they went up, and even producers enjoyed some benefit. Their surplus went up. But somebody has to pay for that expenditure, all right? The government doesn't just create this stuff. Somebody had to pay for it. The tax expenditure actually does not outweigh the surplus gain. So part three, we would say no. The surplus gain does not outweigh the deadweight loss. I should say the tax expenditure. And due to this, because of this deadweight loss, what is the loss of surplus is equal to 300. Is equal to 300. And that's how we would answer a subsidy question. All right. So I didn't show the derivations or much of the calculations on screen, but the ones that I didn't show are exactly the same as the example one. All right. The ones that I wanted to show was the thing with the expenditure and how like all of this stuff right here, and then this one here. All right. And so that's how we want to analyze subsidies to a market. We want to see if that expenditure um, can be compensated for by the surplus gains, by the welfare gains. All right. Very good. Very good. Um, Now, how do we consider price controls? All right. How can we consider price controls? This is when the government wants to interfere with the market or regulators want to interfere with the market, not through direct taxes or subsidies, but putting caps on things. Price ceiling is a cap. Ceiling means you can't go higher than that. A price floor is the minimum. It means it's a baseline. All right. So we will consider what happens when we have a price ceiling. And then suppose we're working with the exact same example as before. All right. So then now I don't even have to redo part one. I know that P star is going to be P star and Q star, and then CS and PS are going to be the exact same as we had above. All right. So if we look above, we look at the pre-subsidy case, we had 100, 150, 2,500, and 5,000. So we had 100, 150, 2,500, 5,000. All right, make sure that's correct. Sure is. So cool. Now, suppose the government enacts a price cap, all right, a price ceiling of $100. So the market price is 150. The government's saying that we can't charge more than $100 for this stuff. How does this affect the market? Now, now, what we want to do, now what we want to do, it's actually, in my opinion, it's a bit computationally easier. Remember, let's look at the supply. Remember we had P supply is equal to 50 plus Q supplied, right? Right, right from the equation given. So if we force, we know that the market price is higher than $100. So if we force 100 price equal to 100, then we have 100 is equal to 50 plus Q. This must mean that Q star is equal to 50. So price is equal to 100 because we're capped at that, and then Q star is equal to 50. What does this do to the market? We're going to have nearly the same as originally. Got intercepts here, here, here. So if we were to redraw quickly, the graph for this market, this is Q, this is B, supply, and this is demand. And then we know that we should be here. We should be here if we didn't interfere with the market. But somebody's intervening. There's some kind of market intervention occurring. This was 150. But now, let's do something like this. All the way across. All right. Since we're forcing this price of 100, the quantity supplied, and that's what I plugged this into right here. Quantity supplied is equal to, we only had 50, whereas we originally had 100. And now the idea, you guys, the idea is that now, let me try to do it in this way. All right. So the idea here is now, remember the market wants 100 things, but there's only 50 to go around because of this price cap. There's not as much people willing to sell at such a low price. So there's going to be a shortage. There's going to be more demand than there is supply. And that's why I drew this right here. Um, if we were to have plugged in demand at price equal to 100, what we would have found is that 100 would be equal to 200 minus 1/2 Q. And in this way, Q would be equal, the quantity demanded is equal to 200. So at this price, at a price of $100, not only 100 people would want it, but 200 people would want this stuff, whatever this item is. But there's only 50 to go around. Let's make these things clear. So there's a shortage of 150 units. That's not a good thing. All right. More people want the thing than there is enough to go around. Then not everybody who is willing to pay for this thing or is able to pay for this thing, not everybody is able to receive that thing. All right. And so this creates a dead weight loss. How we want to compute this is what we want to do is what you want to do is we know the producer side is actually the easier side right here. We know that the producer surplus is this red area. All right. So now we know that the producer surplus is simply 100 minus 50. So that's 50. So 50 times 50 times 1/2 is going to be equal to 1250. And then the consumer surplus, well, let's look at the demand curve. All right, remember, this is an inverse demand curve. All right. The consumer's price willingness to pay at a quantity equal remember, producers are only producing 50. There's only 50 things to go around. So when quantity equals 50, this is equal to 200 minus 1/2 of 50 equals 175. So the willingness to pay is 175. What I'm trying to get at is that there are some people who are willing to pay this high price. Since there is a shortage, the people that are willing to pay the most will get the item. All right, this is how efficiency works. This is how we want to talk about an efficient distribution, efficient allocation of resources, excuse me. So what that does is that reduces the consumer surplus to only that amount that is the blue triangle right there. Because now the the only not everybody's being served, I should say. Let me leave it at that. Not everybody's being served. So we're losing out on a lot of consumer surplus. So now the consumer surplus is that 200 minus 175 times 50. And so that's 25 times 50 times 1/2. And this should be 625. I think so. Yeah. Yeah, that's correct. Yeah, that's correct. So now total surplus is equal to only 1875. And then let me do that. This is the quantity supplied. When we force the sellers to sell for P equals 100, we know that this is going to create a shortage because at a price of 100, at a price of 100, there's a quantity demanded of 200, but a quantity supplied of only 50. So this gives us the shortage of 150 units. And the willingness to pay at 50 units is 175. And so that's what we use in our consumer surplus calculations. And that's how we do the producer surplus calculations. And that's what gives us total surplus. So this is how we analyze the effects. Oh, and then I guess I didn't write it, but we will. Dead weight loss. What's the change in the loss of surplus? Remember, total surplus was up here. It was 7,500. So we went from 7,500 total surplus all the way down to 1875. Quite a large loss of surplus. That difference is the deadweight loss. And that should be 125. 5625? I think so. The deadweight loss is equal to 5625. Huge, huge. This is why people aren't so quick to jump in and enact like rent control policies. Because all this is going to do is restrict supply more. All right. If we're going to reduce, we can only force landlords to charge so much for rent, then not as many people are going to rent out their buildings or become or be willing to put up capital to make new buildings because it just won't be profitable for them as an investment. Um, so that's why people are a little bit hesitant to enact rent control policies. But yeah, that's how we want to handle price controls. All right. And then the last topic that I want to talk about is trade policies when considering tariffs. And we basically, we just want to break this down. I'm going to give just a high level overview because I don't plan to test on this, but I still want you to get the information. Might be a homework question on a later homework, but this will not be on the test. The tariffs part. We consider two general cases. In case one, we don't produce anything at home. We always have to buy from abroad. So no domestic producers. In case two, maybe there are domestic producers and a foreign producers and foreign producers. How does this change things? All right, let's analyze. So in case one, no domestic producers, then we can only import things. So we'll have a demand and a supply. All right. So as I've written here, if a country does not produce something on its own, then we have no choice but to import it. All right. In this case, if we enact tariffs, we are going to be the ones paying for 100% of the tariff. All right. We have no bargaining power. It doesn't matter how much demand we have no bargaining power. So if a tariff is enacted, then this will simply shift supply upwards by the amount of the tariffs. We go from S to S prime. And of course, this is going to reduce the quantity from Q to Q prime, and it's going to raise prices. There's going to be less stuff to go around, and the stuff that is around is going to be more expensive. All right. The easy lesson. All right. Now, notice this is an upward sloping supply curve. Um, but we want to consider what about perfect competition? All right. Perfect competition, the world price is fixed. So demand stays the same. And then in this case, what if the world price is fixed? This is the P world. What if world price is fixed? Well, if we add a tariff and we're paying the world price already, but we're like, the government said, no, no, you have to pay us some more. Well, then those foreign producers are going to just charge us more for it. And so they're going to just add that tariff onto us. And so we get the same results that the price is now higher and quantity is now lower. Go from Q to Q prime. All right. So we have the least amount of bargaining power if we don't produce this stuff at home, right? If we don't make it at home, where are we going to get it? We have to go somewhere else to get it, and we don't have much of a leg to stand on. All right, you don't have much bargaining power in that case. So now let's consider the other case. Let's consider the case of domestic and foreign producers. All right. In this case, in this case, let's do something like this. We'll have the demand, and then we'll have the world price. The idea, the idea is that now we will have, when we produce this stuff at home, then we'll have a supply curve. For example, if we're in the States, I'm in the States right now, this is the USA supply curve, and then this is the USA's demand curve. But this is the world price, all right? So why would we even import things in the first place? It's usually because it's cheaper to get them outside of borders. So that's why we want to import things. So our domestic producers, our guys at home, they can keep up to an extent. Remember that marginal cost increases with quantity. So our domestic guys, we will follow them, or we will trace the supply curve up until the point at which price equals marginal cost. And then it's no longer profitable for the domestic guys to produce at home. But we have more demand than supply. All right. Following this world price is low, right? Equilibrium in the US would have been a higher price. It would have been something up here. But since world price is lower, our demand is very high. Our demand is very high. So this leads us to a shortage. We want Q1 amount of things, but we can only make Q0 amount of things. Thus, we have a shortage. All right. We have a domestic shortage because people want Q1 amount of things, but producers can only produce Q0. So we must import this difference. We must import the shortage, the amount. Now, what happens if we enact a tariff? What happens if we produce this stuff at home, but we also import it from abroad? And now what happens when we put a tariff on that stuff? Well, we'll still have our domestic supply curve, our domestic demand curve. Do something like that, something like that. All right, we still have these things. And then we have a competitive world price. And then now we have the price, the world price plus the tariff. So we remember that this was our original. We had Q0 and Q1. Well, now if we enact a tariff, now the effective price has gone up, and our guys that are producing at home, our domestic producers, now they're able to sell a little bit more. They're able to be a little bit more competitive because the price has gone up. So now they're willing to produce, they're willing to sell more things because now they're willing to sell Q prime amount of things because they will receive a higher price for those things. All right. So now the producers, now our producers, our domestic guys are eating. All right. Now they're enjoying a little bit. All right. Unfortunately, there is still a shortage. There is still a shortage because for one reason or another, we want many more things. And then at this price, the world price, even with the tariff, is still pretty competitive. We can't produce all of this stuff at home. So there is still a shortage, but now the shortage amount has decreased. All right. The shortage amount was this great gap right here, but now the shortage amount is this smaller gap right here. So the shortage has decreased and producers are enjoying more stuff. All right. Producers are enjoying more stuff. Um, and then what I should have done is that up here in our original case, before the tariff, remember we were importing stuff, so the consumers were able to get all of this stuff, all of that surplus, but the producers were the guys that were that needing some help, right? So the idea with tariffs enacted smartly is that the intention is to protect domestic industry. What we will see though is that this still has some consequences, even though it does this will help the domestic guys, right? But with tariffs, the idea is they're trying to target the red area. They want to make that area bigger. All right. So now with the tariff, the effective price has gone up, and so our producers are benefiting more. Our producers are benefiting more. All right. Now the consumers are not benefiting as much because they're having to pay a higher price. Because they're having to pay a higher price. And then let's notice something. Let's notice something that well, first, of course, the size of the consumer surplus has gone down. Consumer surplus has gone down. Producer surplus has gone up. What about tariff revenue? Tariff revenue? Well, they're selling this much. I'm sorry. The amount of the tariff is this gap right here, right? So that gap right there, the difference between the world price and the world price with tariff, the only difference is the tariff itself. So, and then we want to see how many things are we importing? All right. We're importing this many things and we're capturing this much tariff for each thing. So the tariff revenue is all of this amount right here. And I don't want to put any numbers because we're not going to look at this stuff too in depth in this class. It's outside the scope and the time frame of this class, but I actually find this stuff very interesting. And so what a like a trade relations person would do, a person that works in the government or any person that's going to work on like a trade bargaining team, is they're going to consider these shifts of surplus, these changes in welfare, and then analyze tariff revenues and compare what is better. Should we enact these tariffs or should we not? That's how we make an informed economic decision about how we should go about trade policies. All right. If you think this stuff is interesting, and I highly encourage you to take an international trade class. I do think we have one here at UW. Or if you're viewing this lecture from somewhere else at a different school, then I highly encourage you to see if you have an international trade class in your economics department, and you will learn more about this type of reasoning and rationale and how does this type of analysis get applied to things that went down in history and the things that might go down in the future. All right. But with that being said, that concludes everything I have for you guys today. That concludes everything that will be on the midterm for this first half of the class. If you have any questions, please don't hesitate to reach out. Let me know. Otherwise, I'll see you guys next time.